Have you ever noticed something about AI models like Deepseek? They're smart, but it feels like they live inside a bubble, especially when you run them locally. For example, in this conversation, the GPT OSS model can't even tell what time is it, and that's not really the model's fault. Local AI models are cut off from the outside world. No internet, no real-time awareness. They can generate text, answer questions, even role-play. But when it comes to real-time data or live context, they simply can't provide an answer. And that's where MCP, or Model Context Protocol, comes in. MCP acts like a bridge between the AI model and the outside world. Instead of leaving the model trapped in its bubble, MCP allows it to securely connect with external tools, APIs, and real-time data sources. Now, let me show you how to create a MCP tool and connect it to the AI model. For that, let's dive into VS Code and install Fast MCP package. And let's start writing a script. All right, now let's start coding. First, we'll import the Fast MCP package, and then build a very simple MCP tool that allows our AI model to fetch the current date and time. To create an MCP tool using Fast MCP, first, create a Fast MCP instance with a name. The AI will recognize the tool by its name, so if you're going to include multiple MCP tools, then make sure they all have unique names. Next, using our Fast MCP instance, we'll create two functions, one to get the current time and another to get the current date. Declaring an MCP function is almost the same as writing a normal Python function. The main difference is that you need to place at mcp.tool right above the function, so it shows up as an MCP tool. And right after the function declaration, you'll add a docstring, just a short explanation of what the function does. The AI model will use that docstring as documentation, so it knows when and how to call the tool. The rest of the function looks just like a normal Python function. The only thing to remember is that every MCP function should return a value. Without a return statement, the AI won't have any output to work with. Now, in the same way, let's create the getDate function. Now, add these two lines at the bottom of your script. The run function starts the MCP tool and tells it to communicate with the AI using standard input and output. Fast MCP also provides another transport method, HTTP, which allows you to run the MCP tool as a server, using the line shown on the screen. This method is perfect for production, or whenever you don't want to run the tools locally. Next, copy the path of your Python script and open LM Studio, or any other LLM software that supports MCP. The steps are very similar across most software. Locate the mcp.json file, or its equivalent, and include your MCP tool by adding the command in args as shown. Then, hit save. Now, when you open the chat interface, you'll see your newly added MCP tool. Enable it, and try asking the AI for the current date and time. It should respond using our MCP functions. Whenever the AI wants to access the MCP tool, it will ask for your permission. You can either click Proceed each time, or select Always Allow, so the AI can use the tool without asking again. As you can see, the AI can now give us the correct time. You might be wondering, why would we even need the AI to tell us the date and time, when we can just check our watch, phone, or computer? Well, this date and time tool is just the tip of the iceberg. With MCP, we can do so much more. Next, I'll show you something even more useful and impressive using MCP. We've already seen it handle something simple like fetching the date and time, but this next example is where it gets really powerful. We're going to give the AI access to a MongoDB database, where it will be able to create collections, perform full CRUD operations on documents, create indexes, run bulk writes, and much more, all through MCP. For that, let's declare the connection URL and the database name in a variable. And let's import the PyMongo package and initialize the Mongo client. And then let's start writing the MCP functions for each operations. Let's write the first MCP function to create a collection with the given name. Now let's write the next one to drop a collection. Now let's write the another one to list all the connections in the database. Now let's write the next one to insert a document into a collection. And now, the next one, to get a specific document from a collection. Now the next one, to update a specific document in a collection. Now the next function, to delete a specific document in a collection. And remember, you don't have to follow this exact docstring structure. What really matters is that it's clear and descriptive enough for the AI to understand what the function does, so it knows when to call it. Now let's write the next function to create an index of a specific field in a collection. Now let's write the next function to insert multiple documents at once. Now let's write the next function to update multiple documents at once. Now, finally, let's write the function to delete multiple documents at once. Now let's test how it works by asking the AI model to create a collection named LLM. But before you ask the AI to perform any operations in MongoDB, make sure your MongoDB server is running. If you're running it locally, you can use the command shown on the screen to start the server. And if your database is hosted on a cloud service, simply update the connection URL in the code with your cloud database credentials. As you can see, the AI model has created the collection in our DB. Now let's ask the AI model to insert 20 documents in the newly created collection. Here, we can see the AI model preparing the documents to be inserted in the collection. And there we go. All the documents have been inserted into the collection successfully. Cool, right? In the same way, you can perform all kinds of database operations with the AI model and MCP. And remember, you're not limited to just these examples. You can build your own custom tools to fit your workflow, whether it's managing databases, automating reports, fetching live data from APIs, processing files, or even integrating with other software and services. That's the power of MCP, turning an isolated AI model into a connected assistant that can actually get things done. And now we've reached the end of this video. If you found this useful, make sure to give the video a like, subscribe for more AI tutorials, and let me know in the comments, what do you think? Also, don't forget to check out my other tutorials for more step-by-step AI projects. Thanks for watching, and I'll see you in the next one.